check the equilibrium EQU of the proposed slab. So I have this question already written out. So again, fill in the top. So it's by Darren Scott. There's only one sheet, so I've got sheet 1 of 1. There's no revisions. You know, if there was ever any changes to this calculation sheet, you would change it from revision A to revision B, etc. You know, when we come to design A here, could the load be so large that it could rotate about the point B, so therefore requiring A to be pointing downwards? So because we're looking at equilibrium, we'll be looking at a different table in our Eurocode. So to date, we've been looking at A1.2b for structures and geotechnics. But on the previous page, we have table A1.2a, which is looking at the design value actions, equilibrium, and in this case we only have one equation, 6, 1, 10, and we have unfavourable is 1.1, that's instead of 1.35 on the previous table, and then in terms of the variable actions it's still 1.5. Again, you know, you've got to read through all of these notes. So this is saying you only apply the 1.5 when it's unfavourable. If it is favourable, you consider it as 0. And we will have another example later on where we've got a couple of variable actions and you can start applying these psi values also to the second variable. So it says the characteristic permanent action GK is 15, our QK equals 8 kilonewtons per meter. So if we were to look at from the point of view of a favourable, so this is looking at the lightest combination, what we would be doing is looking at our 15 kilonewtons per meter GK, and we'd be looking at our imposed on there, and then we've got our GK, our permanent on here. But for a favourable, you'll be not considering your QK value. So when considering favourable actions, what we have is 0.9, that's multiplied by our GK of 15, plus our gamma Q is 0 when favourable, so 0 times by 8, so we've got 13.5, and then looking at our unfavourable condition, again we've got equation 610, we've got 1.10 times by GK and 1.5 times by QK, and the worst case is put the largest value, our unfavourable action, on the end to allow it to rotate around, and in terms of the load that's stopping it from rotating, we put in our unfavourable there. This gives us the situation when it might rotate around. We can find out what our reaction is at A to see whether it needs to be pointing upwards or downwards. So if we took moments around B.
So work through the final equation to find reaction at A. You'll find that the reaction will in fact be negative, so it will have to be holding down in terms of equilibrium.